This is Enzymes Part 2 by Emily Brake. There are a variety of different ways to regulate enzyme activity, 3 of which are cofactors, competitive inhibition, and allosteric inhibition. A cofactor is a molecule that will bind somewhere on an enzyme in order to assist in facilitating reactions or by assisting substrates to bind to their enzyme. You'll notice on this enzyme that while there are substrates bound to the active site, they are not able to adequately use induced fit. The cofactor would assist the enzyme by binding to this piece here, assisting the enzyme in binding to its substrates. Cofactors will also donate different atoms or electrons to the enzyme in order for the chemical reaction to take place. There are certain enzymes that are not able to function without their cofactors present. Competitive inhibition is a way for the body to halt enzyme activity. This is done when the competitive inhibitor binds to the active site in place of one of the substrates. A competitive inhibitor is usually similar in size or shape to the substrate. When a competitive inhibitor is bound to the active site in place of one of the substrates, it will prevent both of the substrates from binding to the active site, thereby stopping the enzyme from producing its desired product. When the body would like enzyme activity to re-begin, the competitive inhibitor will unbind and leave the active site, allowing for the other substrate to bind, restarting the chemical reactions. An allosteric inhibition is where molecules will bind to not the active site, but a different site called the allosteric site. When an allosteric inhibitor binds to the allosteric site, it changes the shape of the enzyme, preventing the substrates from binding. When this occurs, it prevents the substrates from binding to the active site, thereby stopping the enzyme and the substrates from completing their reaction. Once the allosteric inhibitors leave the enzyme will return to its normal shape, allowing for the substrates to bind to the active site again and react.